Hello, this is our final presentation about the GoGreen project. As you can see here, we have two VPC, one for the development, one for the production. And for each environment of the VPC, we attach with the internet gateway. This allows the public internet connection from the VPC to the internet. And for the subnet, we have 8 subnets. 2 of them are public. The rest 6 are private subnet. For the first 4 subnet located in the US East 1A availability zone, and the rest 4 located in another AZ. This is to issue the high availability design. For the next is a route table. Route table that determines where the traffic and the network from my subnet or gateway is directed. So in the public route table, we allow the traffic to from the internet gateway and all the traffic within this VPC environment and associated with 2 public subnet. For the verb tier and the application tier, we also follow the same design principle and associate with each subnet respectively. For the net gateway, this is used to instance in private subnet to connect the service outside the VPC, but the service outside external service cannot initiate a connection with those instances. So we have 2 net gateway here and located in the public subnet. For the security group, we have 5 security group here. For the first one is a public security group. This allow all the inbound rules and allow all the outbound rules. For the verb tier security group, they will only receive the internet connection from the public security group, and application tier security group will only accept the traffic from the verb tier. Also, finally, they can reach the database tier. For the next one is network ACL. This is allow or deny specific inbound or outbound traffic at subnet level. And here we temporarily allow all the traffic to be allowed. And also we can replace the IP address of a GoGreen over here to only allow the traffic from the GoGreen. For the instance, we have a 1 bastion host located in the public subnet, and we have divide all the design into loosely coupled design, just in case any single point failure, so the system can still continue running. And for the first is a verb tier, we have 2 instances located 2 different private subnet, and also same design applied to the application tier and the database tier. We can also test the connection about this. So we first located our key, and we add this key to the SSH certificate. Yeah, it shows identity added. So we can connect it to the public instance with this key. First, we need to find the public IPv4 address of this instance. Yeah, it's wonderful. It shows that we successfully connected to the public instance. As you can see here, the IPv4 address exactly matches the private IPv4 address here. Next, we can go further to the private subnet, which is this verb tier. We first copy the private IPv4 address, then replace with this. So again, we can see that the IPv4 address show up here exactly match the IPv4 address show up in the verb tier subnet instance. So which means we successfully connected to the instance in the private subnet. And for the we use application load balancer to distribute the incoming application traffic across multiple target and virtual applicants in one or more availability zone. For the web application here, we use the internet facing and let it cross two availability zone in US East 1A and 1B. And for the database and the application tier, we only apply the internal scheme and let it across to availability zone as well. For the auto scaling, it can monitor my application and automatically adjust the capacity to maintain the steady performance and with the lowest possible cost. For the verb tier auto scaling, we set some capacity rules to only run one desired capacity with maximum to the 10. And we also enable the SNS notification. If there's any unexpected issues happen, they will send the message to the administrator. And also for the same design applied to the database auto-scaling group and the application tier auto-scaling group.
Next, we are going to talk about S3 bucket, CloudFront, and Route 53. First, we create a S3 bucket, name it as GoGreen bucket 1. Then we choose ACL enable and clear the block all public access and bucket versioning enable. Next, we upload the file. And we wait until the status is successful. Then we can add a bucket policy. We make sure that the name is same as your bucket. Then we can check the index HTML. We can see the website is successful. Next, we change the status website hosting to be enabled and the index document to be index HTML. Finally, we add a management, a life cycle rule. There are two life cycle rules. One is for the current object. Move the current version of our object and it also can expire the current version of object. Next, we create a non-current life cycle. It can move the non-current version and it can also delete the non-current version. And I set it as 5 years to delete it. It can help cost optimization. Then we can move to CloudFront. First, we can create a distribution. We need to copy the S3 bucket to endpoint here. So we put it here as original domain. And the rest of things we can just leave as default. And copy the domain name. We can see the website is success. And finally, we can move to Route 53. First, we create a hosted zone. We name the domain as GoGreen Insurance GoGreen Insurance.in. And we copy the domain name to create a new record. Or we can switch to the wizard. Choose the cloud distribution and paste it here. So now we can see. And thank you for watching.